Hello everyone, welcome back to our channel. In today's video, we are going to learn about NumPy Matrix in Python. If you are working with data science, machine learning, scientific computing, or even image processing, you will come across matrices frequently. Today in this video, I'll explain what a matrix is, how to create matrix using NumPy, how it differs from NumPy array, and how to access individual rows, columns, and elements. We'll also learn about matrix properties, performing different arithmetic operations, understanding matrix multiplication, and finally, we'll see how to transpose a matrix with some practical examples. By the end of this video, you will have a solid understanding of NumPy matrices and you will be able to use them confidently in your own Python projects. So, let's get started. Before we start writing any code, let's first understand what a matrix actually is. Matrix is simply a rectangular arrangement of values. You can think of it as a table where data is organized into rows and columns. If you are ever worked with an Excel spreadsheet, then you will already seen something very similar. Every spreadsheet has rows running horizontally and columns running vertically. A matrix follows the same idea. Looking at the example on the screen, we have 3 rows and 3 columns. Since both dimensions are 3, we say the shape of matrix is 3, 3, which means 3 rows and 3 columns. One important thing to remember is that every row usually contains the same number of columns. That's what gives a matrix a rectangular structure. Matrices are extremely useful because they help us organizing the data in a structured format. That's why they are used in the areas like machine learning, data science, computer graphics, image processing, and many scientific applications. For example, imagine you are storing the marks of students. Each row represents one student, while each column to represent a subject. Simple real world example of matrix. Let's look at this example. Here we have three separate lists placed inside outer list. You can see this is the outer list and inside that we have placed three separate lists. Each inner list represents one row of the matrix. Since there are three inner lists, we have three rows and each row contains three values. So we also have three columns. You can see here. Together, they form a rectangle collection of values, which is exactly what we call a matrix. Now we know what a matrix is. Let's see how we can create it in Python. There are multiple ways to create matrix when working with NumPy. The three most common approaches are using np.array, np.matrix, and a normal nested Python list. Out of these, the most recommended approach today is np.array. It is flexible and works well with almost every NumPy operations. The np.matrix function is still available, but it is considered as an older approach and it is not recommended for new projects. A nested list is simply a regular Python data. While it looks like matrix, it doesn't provide the optimized mathematical operations that NumPy offers. So, in this video, we'll mainly focus on np.array function since that's the approach you will use the most in real-world applications. Let's understand this code step by step. I'll explain this in Visual Studio Code. I'll paste the code directly. Now I'll explain all the terms in this code. In the first line, we are importing the NumPy library and giving it the alias name as np. This is the standard conventional followed by almost every Python developer. Next, we are using np.array to create our matrix. Inside the array function, we'll pass nested list. The first inner list become the first row and the second inner list will become the second row. Finally, we'll print the matrix to verify that it has been created successfully. I'll run this code. As you can see, NumPy prints the data in a clean matrix format. Here we have two rows and three columns. So shape of this matrix is 2, 3. Once the matrix is created, we can easily access its elements and we can perform calculations and apply different mathematical operations. That is one of the biggest advantages of using NumPy over normal Python list. Now we know how to create a matrix. Usually, many people think that NumPy matrix and NumPy arrays are exactly same because they both look similar and store data in rows and columns. But in reality, they are different in both capabilities and its behaviors. Let's first talk about ND array, which is shown here. An ND array is the main data structure in NumPy. In fact, almost everything you do in NumPy uses an ND array behind the scenes. One of its biggest advantage is that it is not limited to just two-dimensional or one-dimensional or three-dimensional or even higher dimensional data. It is also more memory efficient, works with entire NumPy ecosystem, and this is the recommended choice, NumPy ecosystem. Now let's look at the matrix class. A NumPy matrix is always two-dimensional. It was introduced in early version of NumPy to make matrix operation easier. Although it has few conventional features, it has limited functionalities compared to NDRA. And it's not recommended for new projects anymore. You may still see it in the older projects, which is why it continues to exist today, mainly for backward compatibility. If you are starting a new project, always choose NDRA unless you are maintaining legacy code. The table at the bottom summarizes the main differences. First, notice the dimensions. A matrix is limited to only two dimensions, while NDRA can represent data of any number of dimensions. Next is history. Matrix is considered a legacy feature, whereas NDRA is the modern and actively maintained approach. One very important difference is the multiplication operator. For matrix, this star performs matrix multiplication. But for ND array, the same this star multiplication operator performs element-wise multiplication. We'll see this difference more clearly when we'll discuss matrix multiplication later in this video. Finally, ND array is fully supported and continuously improved, whereas matrix may eventually be removed in future version of NumPy. Let's verify this with a simple example. Here I am creating one object using np.matrix function and then another using np.array. Even though both contain the same values, they are actually different object types. When I print their types, Python clearly shows that one is NumPy matrix while another is NumPy array. To show that, I'm using print function and type function and I'm passing these two different variables, matrix and array. If I run this code, you can see the type of these two variables. As I said, one is class NumPy matrix and another is class NumPy ND array. In NumPy development, we'll almost work with ND array. So I'll continue using this approach throughout this video in all examples. The next step is learning how to access the data stored inside it. In NumPy, we use indexing and slicing to access individual elements. To access individual elements, complete rows, complete columns, or even smaller part of the matrix called submatrix. Before we look at the example, there is one important rule you should always remember. NumPy follows zero-based indexing. That means counting doesn't start from 1, it starts from 0. Look at the matrix on the screen. The row indices are 0, 1 and 2, while column indices are 0, 1, 2 and 3. So, whenever you want to access an element, NumPy first look at the row index and then column index. Now let's see single element. Let's start with simple example. Here we are using matrix of 1, 2. First value represent the row index and the second value represent column index. Since indexing starts from 0, row index 1 actually refers to the second row and column index 2 refers to third column. The value stored there is 7, which is exactly what NumPy returns. If you see here, first is 1, 1, we have come here and 2, 0, 1, 2. 1, comma 2 will result in 7. Now we'll see entire row. If you want to complete row instead of single value, you only need to specify the row index. Here we are using matrix of 0. This returns the first row of the matrix which contains the values 1, 2, 3 and 4. These we are telling whole 0th row. Now we'll see how to get entire column. To access the entire column, we can use a colon for the rows. The colon simply means selecting all rows, which I have written here. Matrix of colon comma 1. Here NumPy will select every row but only one column at the index 1. In submatrix, sometimes you don't need the entire matrix. You may only want a smaller section of it. That's when slicing becomes useful. Here I am using matrix of 0 colon 2 comma 1 colon 3. This first part will select columns 0 and 1 and this second part will select columns 1 and 2. Together they return a small matrix containing only those values. 2, 3 and 6, 4 are the values. Let's see an example for this. First, I've created a simple matrix in the matrix variable with 3 rows and 4 columns. We'll use the same matrix to understand different indexing techniques. In the first print statement, I'm simply specifying the row. In the first print statement, I'm accessing element at the row index 1 and column index 2, which will return value 7. And in the next print statement, we'll specify a row index as 0 and NumPy will return first row. In the next line, we have used colon before comma. Colon means selecting all rows, then we'll specify column index 1. And as a result, NumPy will return complete second column. Finally, I'm using slicing. Rows 0 through 1 and column 1 through 2 are selected. It will produce a small matrix that contains only those values. Now, you can see indexing and slicing makes it very easy to work with matrix data. Writing loops to find values. Before we continue with the video, I would like to quickly share one of the Python projects that I recently built. This is a password protect PDF application developed completely in Python. The main purpose of this tool is to help you secure your PDF documents by adding password protection. If you have important files like reports, invoices, certificates, contracts, or any confidential documents, you can encrypt them so that only people with the correct password can open them. The application is designed with a simple user-friendly interface, so you don't need any advanced technical knowledge to use it. Here is how it works. First, you simply select a PDF file that you want to protect. Then, enter password that you want to use for document. Once you click the encrypt button, the application securely adds password to your PDF and it creates new protected file while keeping the original PDF unchanged. Along with password protection, the tool uses secure PDF encryption, making it very safer to share sensitive documents with clients, colleagues, or team members. If you are interested in learning how these projects work, or if you would like to use it in your own projects, you will find the download link and more details in the description below. Now let's continue with our video. Now we know how to create matrix and access its elements. Let's learn about some important matrix properties. These properties help us understanding the structure of our data before performing any operations. In real projects, checking these properties will be good because they help in preventing errors and make code more reliable. Our first property is shape. The shape property tells us the dimension of matrix. It returns a tuple in the form of rows and columns. In our example, the matrix has 3 rows and 3 columns. So the output is 3, 3. This is useful before performing operations like addition or multiplication because many operations require matrices to have compatible shapes. Next is NDIM, which stands for number of dimensions. Since a matrix is two-dimensional, the value returned is 2. If you are working with vectors, images, For higher dimensional data, this property will tell you how many dimensions your data has. Next property is size. Instead of rows or columns, this written total number of elements present in the matrix. Our matrix contains 9 values, so the size is 9. Finally, we have D type. This tells us what type of data is stored inside matrix. Here, every value is an integer. So, NumPy returns in 64. Knowing the data type is useful because it affects both memory usage and performance. Let's see an example for this. Here, I've created simple 3 into 3 matrix. Then, I'm printing 4 commonly used properties. The first one returns matrix dimension, then second tells the number of dimension, and third will count the total elements, and the last property will show the data type stored in the matrix. Let's run this code. You can see whatever I explained in properties, same output it is giving. Once we know our matrix properties, we can start performing arithmetic operations. That is our next topic. One important thing to understand is that NumPy performs NumPy performs arithmetic element by element. This means each value in one matrix is combined with the value at the same position in another matrix. This behavior is called as element-wise operation. Let's start with addition. When we write a plus b, NumPy adds corresponding elements from both the matrix. For example, the first element of A is 1 and first element of B is 5. So the result will become 6. You can see here 1 plus 5 will become 6. The same process will continue for every element. Subtraction also work in the same way. NumPy subtracts the corresponding elements from each matrix one by one. Next is scalar multiplication. A scalar is simply a single number. When we multiply the matrix by 5, every element inside the matrix is multiplied by 5. 1 is multiplied by 5, 2 is multiplied by 5, you are getting 10, 3 is multiplied by 5, you are getting 15. In the same way, when it comes to division, every element in the matrix is divisible by scalar value. So, if we divide by 5, every element is divided individually. One important rule to remember is that when performing element-wise operation between two matrices, both matrices must have exactly the same shape. If the dimension didn't match, NumPy will usually generate an error. Let's see an example for this. I've created two matrices. Name them A and B. First, I'm adding them together. NumPy will add every matching elements from both the matrices. And then we'll subtract one matrix from another. Again, comparing matching positions. After that, we'll multiply matrix A by 5, which multiplies every value inside the matrix. Finally, I'll divide the matrix by 5 so that every element is divided individually. As you can see in the output, what I explained previously, the same result you will get. Now let's move to one of the most important topics in NumPy matrix multiplication. Earlier, we learned that multiplication operator performs element-wise multiplication for NumPy arrays. But if you want actual matrix multiplication, you should use either at operator, which is the recommended approach, or you can use np dot function. Before multiplying two matrices, one rule must always be satisfied. That is, the number of columns in the first matrix must be equal to the number of rows in the second matrix. In our example, matrix A has shape 2 into 3 and matrix B has 3 into 2. Since the inner dimension match, multiplication is possible and the result will be 2 into 2 matrix. Let's understand how one value is calculated. To find the first element, we'll multiply the first row of matrix A with the first column of matrix B. That is 1, 7 multiplied first, and then we'll add that for second 2 into 9 plus in the same way we'll get 7, 18, 33 and final result will be 58, which you can see in the result. All other values are calculated in the same way by multiplying rows with columns. Let's see an example for this. Here I've created two matrices. First I'm using the add operator and then I'm using np dot method. Then I'll run this code. As you can see, both produces exactly same output. I recommend using add operator because it is cleaner and easier to read. The final concept we'll learn is the matrix transpose. A transpose is simply means interchanging rows and columns. In other words, every row becomes a column and every column becomes a row. You can understand like this. Look at the example. The original matrix has 3 rows and 4 columns. After applying the transpose, it became 4 rows and 3 columns. Important thing here is values don't change, only their position will change. Let's see an example for this. I've created a matrix with 3 rows and 4 columns. By writing A, T, NumPy automatically swaps the rows and columns and will print the TAT. If I run this code, the result is a new matrix with 4 rows and 3 columns, exactly as we saw in the slide. This is the easiest and most commonly used way to create a transpose in NumPy. In this video, we started by understanding what is matrix, how it differs from NumPy array. Then we learned different ways to create matrices, access individual elements, rows, columns, and submatrices using indexing and slicing. We also explored important matrix properties like shape, endim, size, and dtype, and performed arithmetic operations, learned how matrix multiplication works, and we used add operator, np dot function, and finally we understood how to transpose a matrix. I hope this video has given you clear understanding of NumPy matrices, how they are used in real Python programs. If you found this video helpful, don't forget to subscribe to our channel for more Python tutorials, projects, and practical programming videos every week. Thank you for watching this video. I'll see you in the next video.